Derivatives of hyperbolic. What is the meaning of the derivatives of hyperbolic? It deals with the relationships between a hyperbola. They are defined based on exponential functions and have properties similar to trigonometric functions, but it is related to the hyperbola. The formulas of derivatives of hyperbolic functions are: the first one is the derivative of hyperbolic sine with respect to x is equal to hyperbolic cosine u times du over dx. The second one is the derivative of hyperbolic cosine with respect to x is equal to hyperbolic sine u times du over dx. The third one is the derivative of hyperbolic tangent with respect to x is equal to hyperbolic secant squared times u times du over dx. The fourth one is the derivative of hyperbolic cotangent with respect to x is equal to hyperbolic negative cosecant squared times u times du over dx. The fifth one is the derivative of hyperbolic secant with respect to x is equal to hyperbolic negative secant times u times hyperbolic tangent times u times du over dx. The last one is the derivative of hyperbolic cosecant with respect to x is equal to hyperbolic negative cosecant times hyperbolic cotangent times u times du over dx. And to exponentially speaking, the first one, which is the hyperbolic sine x, is equal to e raised to x minus e raised to negative x over 2. The second one is the hyperbolic cosine x is equal to e raised to x plus e raised to negative x over 2. Hyperbolic cosecant x is equal to 2 over e raised to x minus e raised to negative x. The fourth one is the hyperbolic secant x is equal to 2 over e raised to x plus e raised to negative x. The fifth one is the hyperbolic tan x is equal to e raised to x minus e raised to negative x over e raised to x plus e raised to negative x. The last one is the hyperbolic cotangent x is equal to e raised to x plus e raised to negative x over e raised to x minus e raised to negative x. All of these are the exponentially speaking hyperbolic formulas. So you're probably wondering, where did the derivatives come from? So here is the explanation of it. The first one is the derivative of hyperbolic sine x with respect to x is equal to the derivative of e raised to x minus e raised to negative x all over 2. Then, using the derivatives of exponential function, you know that the derivative of e to the x is simply e to the negative x, and the derivative of e to the negative x is negative e to the negative x. And therefore, we shall have e raised to x plus e raised to negative x all over 2. So, the e raised to x plus e raised to negative x all over 2 is equal to hyperbolic cosine x. According to the derivatives of exponential function, the function that represents of e raised to x plus e raised to negative x all over 2 is equal to the hyperbolic cosine x. So, in general, the derivative of hyperbolic sine with respect to x is equal to hyperbolic cosine u times du over dx. For the reason that the hyperbolic sine x is equal to e raised to x minus e raised to negative x all over 2. We can see here that it is e raised to x plus e raised to negative x all over 2 is equal to hyperbolic cosine x. And also in hyperbolic cosine x is equal to e raised to x plus e raised to negative x all over 2. So again, in general, we will have the derivative of hyperbolic sine with respect to x is equal to hyperbolic cosine u times du over dx. The second one is the derivative of hyperbolic cos x with respect to x is equal to the derivative of e raised to x plus e raised to negative x all over 2. So, the derivative of hyperbolic cosine x with respect to x is equal to e raised to x minus e raised to negative x all over 2. We all know that the derivative of e raised to x is equal to e raised to x, and the derivative of positive e raised to negative x is equal to negative e raised to x all over 2. We can see here that the hyperbolic sine x is equal to e raised to x minus e raised to negative x all over 2. So, e raised to x minus e raised to negative x all over 2 is probably equals to sine or hyperbolic sine x. In general, the derivative of hyperbolic cos x with respect to x is equal to hyperbolic sine u times du over dx. The third one is the hyperbolic secant x is equal to 2 all over e raised to x plus e raised to negative x. So we're going to rewrite the equation. In differentiating the derivative of 2 all over e raised to x plus e raised to negative x, we must use the formula of quotient rule. So what is the formula of quotient rule? The formula of quotient rule is v du minus u dv all over v squared. We can use the formula of v du minus u dv all over v squared to differentiate this equation. So now, we have our u, which is 2. The derivative of 2 is equal to 0 because we all know that the constant number is probably 0. And our v is equal to e raised to x plus e raised to negative x. So the derivative of v is equal to e raised to x minus e raised to negative x. So now we have the derivative of u and the derivative of v. So now we were going to plot the equations using the quotient rule. For v, we have e raised to x plus e raised to negative x. And for our du is probably 0 minus our u, which is 2, times the dv, which is e raised to x minus e raised to negative x, all over v squared, which is the e raised to x plus e raised to negative x squared. We notice in the numerator that we can cancel out the e raised to x plus e raised to negative x times 0. After we cancelled out the e raised to x plus e raised to negative x times 0, we only have the negative 2 times e raised to x minus e raised to negative x all over e raised to x plus e raised to negative x squared. We notice at the denominator that we can split it into two functions. which is 2 all over e raised to x plus e raised to negative x times e raised to 2 minus e raised to negative x all over e raised to x plus e raised to negative x. The function of the right side, which is the e raised to 2 minus e raised to negative x all over e raised to x plus e raised to negative x, we can call this as the hyperbolic tan x. On the left side, we notice that the function is what we called as the hyperbolic of secant x, which is 2 all over e raised to x plus e raised to negative x. So by the way, do not forget to put a negative sign, because when we talk about a hyperbolic secant x or hyperbolic secant u, there is always a negative sign on it. The negative 2 all over e raised to x plus e raised to negative x probably equal to the hyperbolic of negative secant x, while the e raised to 2 minus e raised to negative x all over e raised to x plus e raised to negative x is probably equal to the hyperbolic of tangent x. That is the general form of hyperbolic secant x. The fourth one is the hyperbolic of cosecant x is equal to 2 all over e raised to x minus e raised to negative x. We all know that the reciprocal of cosecant is 1 all over hyperbolic sine x. Now, we will going to differentiate the reciprocal of hyperbolic cosecant x, which is 1 over hyperbolic sine x. By dealing with this problem, we need to use the formula of quotient rule. The formula of quotient rule is the v du minus u dv all over v squared. So for our v, we have here our hyperbolic of sine x, while the du, we have here the constant, which is 1, is probably 0, minus the u, which is 1, times the dv, which is the hyperbolic cosine of x all over hyperbolic of sine x squared. So, cancel the hyperbolic of sine x times 0. So, we will only have the negative cos hx or hyperbolic of cosecant x all over the hyperbolic of sine x squared. So again, we noticed that at the denominator, we can split it into two functions, which is 1 over hyperbolic sine x times hyperbolic cos x all over hyperbolic sine x. The function of the right side, which is the hyperbolic of cos x all over the hyperbolic of sine x, is actually called as or equal to hyperbolic of cotangent x. And the function of the left side, which is 1 all over hyperbolic of sine x, is called as or equal to hyperbolic of cosecant x. Again, do not forget to put a negative sign of this function in the right side, which is the negative cos h or hyperbolic cos x all over hyperbolic sine x. In general, the derivative of hyperbolic cosecant x with respect to x is equal to hyperbolic negative cosecant x times hyperbolic cotangent x. Again, The 1 all over sine x or hyperbolic of sine x is what we called as or equal to hyperbolic cosecant x, and the negative cosecant x or hyperbolic of negative cosecant x all over hyperbolic sine x, which is equal to the hyperbolic of cotangent x. Again, in general form, derivative of hyperbolic of cosecant u is equal to hyperbolic negative cosecant u times hyperbolic of cot u du over dx. The last but not the least, which is the hyperbolic of tan x is equal to e raised to x minus e raised to negative x all over e raised to x plus e raised to negative x. Now, we will going to rewrite the equation. Again, as what we see at the equation, we will probably needed to use the chain rule formula. So we all know what is the chain rule formula, which is the v du minus u dv all over v squared. So we have our v, which is the e raised to x plus e raised to negative x. And for our du, which is the e raised to x minus e raised to negative x, is equal to e raised to x plus e raised to negative x minus, which is our v, we have our u, which is e raised to x plus e raised to negative x times the e raised to x minus e raised to negative x. So all over the v, which is the e raised to x plus e raised to negative x squared. If we look to the denominator, we can notice that we can still split this equation into two. So we need to distribute these variables, which is e raised to x times e raised to x. So it is equal to e raised to 2x plus e raised to x times plus e raised to negative x, which is 2. Again, we need to substitute. So e raised to x times e raised to x is equal to e raised to 2x. Then minus 2 plus e raised to negative 2x. The v squared, which is the e raised to x plus e raised to negative x squared. We notice that the e raised to 2x plus e raised to negative 2x is we can cancel this out. And also at the right side, we can also cancel out the e raised to 2x plus e raised to negative 2x. 2 times 2 is equal to positive 4 over the square root, which is e raised to x plus e raised to negative x squared. We can probably rewrite this equation, which is the common factor of 4 is 2. So 2 all over e raised to x plus e raised to negative x raised to 2, or the square root of 2. Notice that if we try to multiply 2 times 2, it will equal to 4. And if we multiply the e raised to x plus e raised to negative x to the power or raised or squared of 2, it will probably equal to e raised to x plus e raised to negative x squared. According to the derivatives of exponential function, the 2 all over e raised to x plus e raised to negative x squared is what we called as the hyperbolic second x. In general, the derivative of hyperbolic tangent x with respect to x is equal to the hyperbolic of secant squared x. We put squared because of the square root of this equation above. Again, the derivative of hyperbolic tan x with respect to x is equal to the hyperbolic of secant squared x. The following are the example problems. If you already know the derivatives of 6 trigonometric functions, and then you can easily recall the derivative of these hyperbolic functions. So, let's begin. Number 1. The derivative of hyperbolic sine 5x with respect to x. So now, we need to differentiate this. The formulas that we must or we need to use are the formulas of derivatives of hyperbolic functions. So, in sine, the formula of sine is hyperbolic of cosine u times du over dx. So as what we were going to write is, first, we have to write the sine h5x or the hyperbolic sine 5x. And for our u, which is the 5x. So what is the derivative of 5x? The derivative of 5x is probably 5. So now, let's copy the derivative of 5x, which is 5, times copy the hyperbolic of cosine 5x. So, the final answer of the derivative of hyperbolic sine 5x is equal to 5 hyperbolic cos 5x. And for the number 2, we have here the derivative of hyperbolic cosine x squared with respect to x. To differentiate this equation, we must use the formula of the cos hx squared, which is the sine hu times du over dx. So now, let's copy the hyperbolic cosine x squared which is the u is x squared. So what is the derivative of x squared? So we all know that the derivative of x squared is, first we know that there is a invisible one, which is 1 times 2 is equal to 2, and minus 2 minus 1, which is x. So the derivative of our x squared is 2x. So now let's put it on the equation, which is the derivative of x squared is 2x times sine h x squared. So now this is your final answer, which is equal to 2x hyperbolic sine x squared. The third one is the derivative of hyperbolic secant 3x squared with respect of x. So now, as usual, we will going to use the formula of the derivatives of hyperbolic functions. The formula of sec hu, which is equal to the negative sec hu times tan hu times du over dx. or the hyperbolic of negative secant u times the hyperbolic of tangent u times du over dx. So, we need to use the formula of the hyperbolic secant u. And then, let's input the equation together with the formula. So, the hyperbolic secant 3x squared times the tan h or the hyperbolic tangent 3x squared times the derivative of 3x squared with the respect of x. So what is the derivative of 3x squared? So probably and anyways, don't forget to put the negative sign. So the derivative of 3x squared is 3 times 2, which is 6x, because it is 2 minus 1 is equal to x. So the derivative of 3x squared is 6x. So now we can see that if we multiply the 3x squared all over the negative sign, it will become 2 negative 6x hyperbolic secant of 3x squared times tangent of 3x squared. So that is our final answer. For the number 4, the derivative of hyperbolic secant raised to 4 times 10x. So we can see here that we have two functions, which is the hyperbolic secant raised to 4 and the 10x. So first, we're going to use the formula of the exponential formula, which is the nu raised to n minus u du. And for our n, we have 4. And for our u, we have the hyperbolic secant 10x. So this equation is we took this in the functions inside the parentheses. For us to solve this equation, we must use the formula of hyperbolic secant, which is the hyperbolic negative secant u times the hyperbolic tan u du. So let's write it here. Negative secant hu tan u du over dx. So now, for our u is, we need to differentiate the 10x. So for our u is, we have the 10x, and the derivative of this, of the u is probably 10. And then, we have to write the formula and replace the u with the 10x. So for our du is equal to, so for the formula is negative secant h times the u, which is the 10x, times tan h times the u 10x. And for the du, which is the derivative of u, is 10. So we notice that we can still differentiate this. So du is equal to, if we try to multiply the negative and the 10, so it will equals to negative 10 sec h times 10x times tan h times 10x. So this is not our final answer. We need to go back to the exponential, formula. So we need to apply the exponential formula. So it is equal to, so for our n, we have 4 for our n. For our u, we have the hyperbolic of secant 10x cube. Why did we use the cube? Because 4 minus 1 is 3. So that's it. And then as we notice, so our du is, we need to copy this. So the bracket, we put the bracket on, and then copy the negative 10 sec h times 10x times 10h times 10x, close the bracket. So as we notice that we can multiply the 4 and the 10x, so it will equal to negative 40. So we notice that the second h 10x and the second h 10x is the same on the parentheses and on the bracket. So we will going to put this into 1. So we're going to write the second h raised to 4 because 3 plus 1 is 4. Then copy the remainder, which is 10x times 10h times 10x. So this is our final answer. For the number 5, we have here the derivative of x cubed sine h times ln x with respect to x. So some of us are wondering if we can still use this formula to differentiate this function, which is the formula of du is equal to the cosine hu du. Sadly, we cannot use this formula because we are dealing with the hyperbolic functions. So what we have to do is we must use this kind of formula, which is the hyperbolic of sine x is equal to e raised to x minus e raised to negative x all over 2. So we have to use that because that is the formula of exponential hyperbolic. The next step that we have to do is to substitute the x into ln x. So e raised to ln x minus e raised to negative ln x all over to 2. So we notice that e ln x is equal to x. I hope we know that when we deal with e raised to ln x, it is equal to x. So we can change this form into x. So into this e raised to negative ln x, we can change this into a negative exponent. So neg minus e raised to ln x minus 1 all over 2. So x minus x raised to negative 1 all over 2. So we need to reciprocal the x raised to negative 1. So it is will equal to x minus 1 over x all over 2. And then we have to times or multiply this function. So x times x is equal to x squared minus 1. And the lower part is probably it have a x, so it will equal to 2x. So now we have our equation. So we can go back into our main equation. So this is the equation of sine h ln x. So this is not the final answer. So as we notice that we can cancel out the x, so it will become x squared minus 1 all over 2. So as we look at the equation, we can multiply the x squared times x squared, so it will become 2x raised to 4 minus x squared. Again, we have to substitute the x squared to the x squared to get the x raised to 4 and the x squared times 1 to get the x squared all over 2. So the next step is we need to get the coefficient, which is the 1/2. then open bracket. So we need to copy the derivative of x raised to 4 minus x squared. Close bracket. So equals to 1/2. Copy the 1/2. So we need to find the derivative of x raised to 4 minus x squared. So we all know the derivative of x raised to 4 is 4x cubed. And the derivative of x squared is 2x. So we notice that we can find the common factor of 2 and 4. So we need to cancel out this 2 and the 4 and also the numerator and denominator of 2 and 2. So it all cancelled out. So it is equal to 2x cubed minus x. So this is our final answer.